Hello and welcome to another episode of the VMblog Expert Interview Series. And today I'm really excited to have with us one of my friends and someone very well known in our industry, Simon Crosby, who's now the CTO at Swim. Simon, it's great to catch up with you today.
It's super, Dave. Thank you for having me.
Absolutely. It's been a while. I know we've done some written interviews and talked over email, so it's good to see you in person.
Yeah,
even if it is over Zoom.
It's over Zoom and we're both getting older.
Yeah.
There you go.
So I guess before we jump into some of the details that I want to talk about today, I wonder, could you give viewers just a quick brief background on Swim, the company, and tell us a little about it?
So Swim is the brainchild of this absolute wunderkind called Chris Sachs. He's about half my age and about 10 times smarter than I am. And, he's a kid who never even went to college. He just started writing code. And what did he do? He solved an amazing problem, which is really how to build models on the fly from streaming data and get them to concurrently compute really powerful insights that you'd never be able to derive normally. So it's a great privilege to be able to work with Chris. So the company is about 5 years old. We've taken about $26 or so million in funding. And we recently launched version 4 of our commercial product, Swim Continuum. It's an open core product. So the core is SwimOS, and you can find it on GitHub at swimos.org. And what's there is everything you need to build massively scalable, distributed applications which deal with real-time data.
Yeah, I think that's a good place to start. I obviously talked about your recent 4.0 news, and wondering if you could explain a bit more about what's the best way to build apps that need to what you guys call analyze, learn, and predict on the fly from streaming.
So, I think that's a perfect way to start, because I think most people are stuck, right? That is, in most organizations see the cloud as hard, right? And they just don't know where to go. And there are like 5,000 Amazon services, and the same from Microsoft, and the same from Google, and they're just stuck. And so I think it's absolutely critical to be able to give people the tools, let people use the tools they already know. And so for us, you just write apps in Java, and UIs are done in JavaScript or TypeScript, and you deploy in containers on Kubernetes, either hybrid or on-prem. It doesn't really matter. We don't care. And so for us, making it easy for developers to achieve unthinkably cool insights is really key.
And what's one of the another kind of new key technologies that everybody's kind of talking about? What's the impact from edge computing?
Yeah, so let's talk about edge for a sec. People talk about edge computing as though it's a thing. Kind of isn't. Edge is where the data comes from. Okay, there's tons of it. I mean, in a large customer, you see behind me, my fake backdrop is a mobile provider where we're tracking it, and optimizing the connection quality for hundreds of millions of devices. Okay, so edge is where all this data originates. Where you process, where you actually get to process it is, the first place you can. Not in a specific place called the edge, right? And so that gets dictated by really two things: wherever you have access, but also where the data is available and unencrypted. And often that is the cloud, right? So edge, for me, edge computing is about how I compute on data from the edge and where is the best place to do it. But it's not as though some color is really important. Now, I do think there is a real opportunity for, in the context of 4 and 5G, for service providers to take advantage of what they call mobile edge compute, which is compute close to their base stations, because that compute has access to all the insights from the radio access network, which is where is every device, and how can I deliver powerful services that know the context for a device and the context for a user, and so on. And I think that's really interesting.
And this whole topic, I'm sort of a noob when it comes to this, but as I'm reading through it, I was hoping maybe you can explain what the real-time analysis of streaming, what does it require?
Yeah. Cool beans. So let's just start with the basics, like Moore's law. Everybody always goes a little about Moore's law, but the cloud is built out of REST and databases, and it's fabulous that way because any old server can do, right? Any old server will serve my requests and stick some data in a database, but it's slow as a result. I mean, there are lots and lots of servers, so it grows wide very well, but it doesn't keep up with memory speeds, okay? So if you have an application which really cares about instantaneous response or always knowing that it is an application where you always have to have the answer, then the idea that you're going to generate a request to a database and sit around for 50 milliseconds while somebody thinks about the answer is not acceptable. So anything where you have to know, like flying drones, or do I apply the brakes, or how do I optimize the connection for this particular device to the network, or where are the widgets in my factory? How do I optimize production and so on? There are tons of use cases where you always have to know. The idea of using a REST-based architecture is just antiquated. It's way too slow, and it's very expensive. So literally this, you can go a million times faster if you keep all data in memory, right? These concurrent, we call them web agents, but think of them for the moment as digital representatives of things in the real world, digital twins. If you can go a million times faster, if all the memory and all the model is already in memory, right? And you just run at CPU speed rather than having to reach out to a database. Because the moment you do that, you're going a million times slower. And a good analogy for the million times number is this. If a CPU cycle is about a nanosecond, let's compare that to an F-18. Okay, it's going about 1,000 miles an hour. Compare it to a banana slug. That's about the same as a million times slower. Okay, so cloud apps today go like banana slugs, and we should be going like F-18s. And if you do that, you can reduce the number of computers you need. So typically in a swim deployment by 90%. So it's huge. So swim is all about staying in memory, building models on the fly from data, and computing as we go.
And one of the things you guys talk about is the notion of continuous intelligence.
Yeah.
What makes continuous intelligence for apps so important these days, and how would you define them?
Yeah, so it's like this. ARM is currently shipping 20 billion cores a year. Okay, that's about 2 million devices per hour that join the internet. Okay, so the volume of data is not decreasing. So anybody who thinks about the world in a big data sense, like collect all data and analyze it later, is just way out of touch. Okay, big data was relevant maybe 20 years ago, but now you just can't afford to. So in, I think, 99% of the applications we're in today, you analyze streaming data on the fly and you produce insights. So you analyze it, you learn, or you predict, or do something with it, and then you throw away the raw data, okay? And that way you turn streams of data into streams of analysis, streams of facts, things you know about the world, right? And the key thing that Swim can do, that I've never seen any other platform do, is find correlations or relationships between things on the fly. that are really important. I'll give you one. We do a ton of work in traffic in Dubai. So here's a use case. Find trucks, all trucks with bad braking behavior. And when they approach an inspector on the street, tell the inspector to pull them over. Okay, so the notion of with bad braking behavior, you have to reevaluate every single time the truck moves and you get GPS update. And the notion of is approaching is a GPS, well, it's a geofence. It's a fine geofencing operation. And you better complete the operation and tell the inspector while the truck is still arriving, not departing. Okay, so you have to do this at scale for every single truck and every single inspector in the whole city, right? And that's a really good use case of a continuous intelligence need.
And then before I let you go, I know you guys, I think it was this week, you announced, we talked about it briefly at the beginning, you announced a new version 4.0. Could you maybe just, touch on, what's new and what's different with the 4.0 release that you guys have just come out with?
Yeah, a lot of the feature set has been driven by our largest customer, which is a mobile provider. And so we're operating at massive scale. And for them, we're processing about 4 petabytes per day. Okay, extremely, it's absolutely huge. So the key growth there has been on scalability, security, manageability, and introspection. The whole point is you can deploy an app and it slides out. It'll run forever. And then also, we've made major strides forward in delivering real-time updates and visualizations to users. Now, the point is this, that we want to enable users to develop their own apps, okay? And so for us, the UI is not something where you type in a search term or every once in a while it updates. It is literally real-time. And if you don't believe me, there are tons of example apps at swim.ai that you can go and play with. So the tools to allow our customers to develop very powerful, visually compelling apps, which are always real-time, both on mobile devices as well as in the browser, is a key part of 4.0.
And so I, appreciate you taking time and explaining, more about Swim and what you guys are doing. For the folks who are watching and want to learn even more about the things that you've talked about, what's the best place for them to go? Obviously, Swim's website. Is there, other things on there that
Yes, so swim.ai has a full overview of the product. If you want to go and start building apps, all you need is Java and a browser, and you're golden. And everything you need is at swimos.org. There are good tutorials there, a bunch of example apps you can take and modify. So for example, we track all the space junk and satellites around the world and going through space. And there are tons of others that you can just take and modify. We integrate with Kafka and all the other forms of streaming products. And so all of those are there, easy for you to adapt. And we can deliver to browsers, to databases, to brokers, and so on. So I would encourage you to go there. And if you need help, just drop me an email. I'm Simon at swim.ai.
Great. Well, Simon, I appreciate it. Thanks again for taking time to speak with VMblog. And hopefully we'll be able to find you somewhere in person in the future instead of over Zoom.
Thank you, David. It's always a pleasure.
All right. Thanks.